All right, in 2.5, we're going to break it up into 2 days. This is part A, and we're going to be solving equations algebraically. Okay, so basically today is just basic algebraic equations, solving them. They are higher order, meaning they have higher powers, so you'll have more than one answer. So I'm just going to run through like 8 examples, and take your time, watch my examples, work with me if you want, and just get your skills sharpened, okay? All right, so 4x to the 4th minus 16x squared. All right, so when you look at this, notice the highest power is a 4. That means there's 4 solutions, okay? So when I finish, or think I'm finished, I need to check to see if there's 4 solutions. So how do I start solving this? I would recommend the first thing to look for is a greatest common factor. Okay, so looking at both terms, what could I factor out of both terms that they have in common? Well, if I take a 4 out and an x squared, I then would have x squared in that first term minus 4 equals 0. All right, well, here is a binomial, and if you recognize this is a difference of squares. This is a perfect square, and this is squared, and there's a negative between them. That means I can factor it as x minus 2, x plus 2. Well, it's a 2 because the square root of 4 is 2. And I bring that 4x squared straight down. Now I would set each component equal to 0 and solve it. All right, well, if I divide by 4, I have x squared equals 0. That means x is 0. So there's actually, this is 2 solutions because this squared means it's a double root. Okay, that's 2 solutions right there. Now this one, if I solve this, I get x equals 2. And if I solve this one, I get x equals negative 2. So back to the beginning, we said there's 4 solutions. Here's 1, 2, 3, 4. This is a double root. Not that you have to know that, but I know it's double because there was an x squared in it to begin with in this part of it. All right, let's try another one. Okay, remember we talked about the first thing to look for is there a greatest common factor? All right, yes, I wouldn't say you can take a 5 out of all of these. And then look at your x's. Can I take an x out of all 3 pieces? I can't. When I take a 5 and an x out, what I'm left with is x squared plus 6x plus 9 equals 0. All right, now I can work on this inner part and factor this. I have x plus 3, x plus 3, and then bring that 5x down equal to 0. And then we're going to set each part equal to 0. 5x equals 0, x plus 3 equals 0, x plus 3 equals 0. All right, well, this is x is negative 3. This is x is negative 3. It's just really a double root. And this is where x is 0. So remember, it's a third power to my polynomial. So it means I need 3 solutions, and I do. I have 0, and I have negative 3, and negative 3 happens to be a double root. Look at number 3. All right, here, I do not have a greatest common factor. I cannot take an x out of all 3 terms. So I need to think about how could I factor this guy. Now, don't let the fact that this is to the 4th and this is squared mess with your mind. Think about it like you would normally. You know, remember we said a times c, they add to b. If you think the coefficients, 1 times 3 is 3, but they have to add to a negative 4. Well, that would be a negative 3 and a negative 1, right? All right, easy enough. Well, then what goes in here? Well, we know it's x something, but x times x to what power times what power would give me x to the 4th. Well, if I put x squared in both of these and I FOIL it back out, I'm going to get a middle term of negative 4x squared, which is what I wanted. And if I FOIL the first terms, x squared times x squared, I would get x to the 4th, which is what I wanted as well. So we're in business here. So I would set each of these factors equal to 0 and solve it for x. So x equals 1, or x squared equals 1, x squared equals 3. Now we know if you take the square root, we would have x equals plus or minus 1. Same thing here, x equals plus or minus 3. Remember our order is to the 4th power, so I should have 4 solutions. Here's 2 solutions, and over here is 2 solutions, so I have my 4 solutions. Let's look at number 4. All right, this is going to work very similarly to the previous one, right? X to the 4th and x squared here. So I'm going to factor it with x squared as my first part of each factor. Then I need to think about, okay, what 2 numbers multiply to 1 but add to 2? Well, that's easy enough. It's just a 1. All right, so notice these are the same, right? That's okay. So I have x squared plus 1 equals 0. X squared equals negative 1. Okay, the square root of both sides. I get x equals, so we know that when you take the square root of negative 1, we get I, right? And that's an imaginary root, so we don't worry too much about it. And it's like a double root. To the 4th power is going to work like a double root. All right, so let's look at number 5. All right, we need to solve for x. That's our goal, right? So we need to move our negative 10 over here. So we're going to add 10 to both sides. So I have 3 square roots of x equals 10. I need to isolate x, so I'm going to divide by 3. So the square root of x is equal to 10 thirds. I need to get rid of the square root, so that means I have to square it. So x equals 100 over 9. Notice x is to the 1st power here in the original, so I'm only going to have one solution for x, and there it is, 100 over 9. All right, so let's look at another one. This has a cube root in it. So I want to isolate this cube root, get that by itself. So I need to move that plus 8 over by changing the sign, make it negative 8. So I have cube root of 2x plus 1 equals negative 8. All right? Now, to get rid of a cube root, hopefully you know that you would cube it. So let's do this. Negative 8 times negative 8 would give me a positive 64. Times a negative 8 again would give me a negative 512. So, cubing the cube root gets rid of the root, so I'll have 2x plus 1 equals negative 512. Subtract 1. So I have 2x equals negative 513. Divide by 2. So x equals negative 513 over 2. And you can just leave it like that. I don't need a decimal. That's good to go. All right, example 7. Let's see what we do here. If you want to pause the video, try it yourself before you see me work it, go for it. It's a great way to know if you're understanding things. But if you're not, here we go. We want to isolate the root. So I'm going to move everything that's not under the root to the other side of the equal sign. So I'm going to subtract 4. So I have the square root of 5x minus 26 equals x minus 4. Now to get rid of the root, I need to square both sides. So that's going to get rid of my root on the left. But remember on the right, I have x minus 4 times x minus 4. And if I FOIL that, I get x squared minus 4x plus 16. All of that becomes x squared minus 8x plus 16. So let's put that in there. All right, so we got lots of stuff going on. Now, what I would recommend, notice the x squared is positive here on the right. We want to keep it positive. So I'm going to move my 5x over here by subtracting 5x. So I'm going to have negative 26 equals x squared minus 13x plus 16. Then I'm going to move that negative 26 over by adding 26 to both sides. So I have x squared minus 3x plus 42. All right, so now, interestingly enough, it's equal to 0. So now I need to factor this guy if possible, or I could use quadratic formula. But let's try factoring. Okay, remember it's a times c, they have to add to b. So a times c would give me a positive 42, and they have to add up to negative 13. If I think about my factors of 42, the only ones that really come to mind, quickest ones are 6 and 7. Well, if I make them both negative and add them, I get negative 13, so it works great. Negative 6, negative 7, x and x. Just like before, we're going to set each factor equal to 0 and solve it for x. X equals 6 and x equals 7. So I have two answers. Perfect. Exactly what I wanted. Number 8. All right, let's try this one. Let's see what we get when we get rid of our square roots by squaring both sides. So I get x plus 1 equals 3x plus 1. All right, easy enough. Subtract 1, x equals 3x. Subtract x, 0 equals 2x. That means x equals 0. And we're done, people. We're done. So really we're just practicing the skills that we know to solve algebraically using factoring, using square roots, squaring square roots, and so on and so forth. Hopefully this is simple enough, and you'll come with questions for me if you have any in class. All right, we'll see you soon.